Hello, in this video I'm going to be discussing Crosstalk and how you can put a via, like a series of vias to create a what appears to be a metal wall in between tracks in order to reduce crosstalk. So what I mean is that we'll have a microstrip with two microstrips, so we'll have this, and then we'll have this situation where there's a little wall here. And what this would be is it would be actually vias, and you could place these. The rule of thumb is that the distance, like the gap where there is no metal, is a wavelength over 10 or less in width. So you can't have it any bigger than that, or like further away from each via. So the wavelength would be you could say that it's a few times the fundamental. So if it's a gigahertz, you would calculate the wavelength for that gigahertz in this medium, and you would then divide that wavelength by 10 and multiply it by a few. Well, you would divide it by a few more integers, and then that would be the maximum spacing between these vias. So pretty much I simulated this, and then I calculated, or I used ANSYS to calculate the crosstalk coefficient. So we had the forward coefficient, and we're looking at it at the very high frequencies where it plateaus, and then we do it for the forward and backwards, and then for this case too. So what we'll do is we'll get a calculator out, and then for the forward crosstalk we're going to divide these to see what we get. So we're going to do 1.608, and we're just going to like take away the 10 mentally, and then we do this, and then we divide it by 0.9562. So, and then we reciprocate it because we did the ratio of the without vias to the with vias. So we know that with vias, the reduction in the forward crosstalk is about the forward crosstalk with vias is about 0.6 times the forward crosstalk without the vias. So if we do that for the backwards crosstalk, we will do 0.0237, and we'll divide it by 0.0141, and then we'll reciprocate that again. And what we'll find is there's pretty much the same ratio. So what we can assume that in this case at least, the crosstalk goes down about to 0.6 what it was without vias when you use these vias. Now, when you use these vias, you have to make sure that the vias, you have enough spacing, because if you are doing a high density interconnect, maybe you don't have enough spacing there to put a via, which is not, you wouldn't force a via in that situation. But if you do have spacing, it would be beneficial to put vias in between them, because then you would reduce the crosstalk. The only other thing you have to realize is that the characteristic impedance may be changed. In this case, the spacing between the via wall and the microstrip is large enough that the characteristic impedance stays pretty much the same, but you would have to make sure that that is not altered from this. That is all I wanted to share.